Okay. Welcome back from the break. Welcome back. Welcome back from the break. Welcome back from the break. Welcome back from the break. Thank you so much for joining again. We'll continue from where we left off. The last time, so where we were discussing on package name, package convention, solid principle, separating responsibilities to classes. We look at how we had data abstraction. We look at how we create objects, we create repository, and we have other services class to manage that, so we can have multiple services and things like that. Okay, I probably want to start by adding interface to this, but not to waste our time. Let's go to the next line of action. The line of action will be looking at database, and JDBC. Database and JDBC. That's what we're looking at currently. And in database, we'll talk about SQL. Now, so what is the database? A database is a data collection solution or data storage solution that is that can be queried, that can be interact with command. That is that you can have data stored in database. With database, data are also logically grouped, just like in our package naming convention, we saw how we separate objects that are related into different groups. And so, like you have a project, you can have a project which translates to a database. And then we have tables. Our tables in Java can be mapped to tables in database. We have database, like I said, as software solution for data storage and retrieval, which can actually be queried using some commands. Data that is stored in database are well structured. Of course, we have different type of databases. We have what we call relational databases. Relational database system. From relational, what it means is that there is a relationship between, or there's a relationship among data that are being stored. There is a relationship. Then we also have what we call a NoSQL. A NoSQL database. NoSQL does not mean absence of SQL. It means that is an unstructured database. NoSQL, and then we have unstructured database. And then we also have, of course, for the unstructured database, we also have key value pair. Is an extension of key value pair database, like map you have seen before. So we also have things like what we call in-memory database. So this kind of database are not stored. They are just instant file that is created to store data, or a kind of logical file that is created in the memory of your server or your application. So that's why they are called in-memory. Most times, this in-memory database are very tiny, kind of database, very kind of tiny. They're like tiny SQL, like H2. Most time, tiny SQL is used for things like a mobile application. Mobile application can have a database on it, so you can use things like tiny SQL on the database. We also have H2. H2, like for Java now, you can write some text data that's stored in the file and retrieved, and it acts as if it were a real database, H2 database. So the other databases like that. So we also have NoSQL. Like I said, is unstructured. They don't maintain data. They do not maintain data integrity. That's number one. They do not. There's something in relational database that is called ACID. ACID has to do with one, atomicity. Atomicity means that an event must start and complete. A transaction must be initiated and it must complete. If you send a package from one source to the end, the full package must be delivered. When the full package is not delivered, you have returned the entire package. You have to, for example, you send a package to an address by courier. If you are sending by courier, which is very expensive, when the address is not found, it is returned. Which means that's an extension. So that package is returned. That package is not dropped anywhere. So that is atomicity. That is completeness of a transaction. Then we have within the ACID, we have completeness. There is also like data integrity. Data integrity means that the part of the data or the structure must at any time must not be compromised. For example, if you have say you have a package, let's use that package as an example, and this package that has been paid for and sent by a courier package, courier service, and it gets to the destination and they realize that package has been opened. That means the integrity of the package has been compromised. You understand? So it's no longer the real package that has been sent, because whatever that is there could have also been stolen. So that is why data integrity is also important in the relational database. So find the details of ACID. Go and read more about ACID. NoSQL means that you don't care whether the whole package is delivered or not, and you don't care whether it's fully formed or not. For example, when you are broadcasting now, a lot of things can be said, but a lot of people may not hear everything that have been said. So in broadcasting over the air, so that is tantamount to no structure, unstructured, where the integrity of data could actually be compromised. You are not interested in the completeness of the package that is being stored. For example, you can also have file system. You can have different files, different images, different data storage, data type that is being stored, or image that is stored in the database. Here, one may have full description, the other may not have full description. One may be tagged, the other may not be tagged. So in such case, you can make use of NoSQL database. Having said that, our focus today is on RDBMS, that is relational database. So in relational database, you have the database, which is provided by any database vendor, but whatever thing they do remains the same. So you have a database, relational database from vendors like Oracle. You have MySQL. you have Postgres, you have Microsoft MS SQL, SQL, you have Sybase, and so on and so forth. So you have different kind of databases here and there. So that's for relational databases. For non-relational databases, which is NoSQL. For NoSQL, you can have things like Cassandra, and the very popular or most popular, we have MongoDB, because there is a version of it that is that is free. That is free. That is free. Okay. Now, so Cassandra, MongoDB, DynamoDB by DynamoDB, that is by AWS, Amazon. So Amazon Dynamo. So those are the kind of the H2 is from Java. It's a Java DB or Java DB and things like that. Okay. Having said that, we also have one very popular one also called Redis. Redis is also a NoSQL database, which can also be used for catch, whichever way you pronounce it, catch. That is temporary storage of data, to increase performance. Now, having mentioned all that, let's deep dive into database proper. Whatever the vendor, the same operation still remain, generic operation by database remains the same. So first, for database, you have database, which is the logical file, and then the database is also composed of what? Tables represent entity and structure, and for each table is organized into rows and columns. Now, the rows are the list of records, list of individual records within the table. A table is a grouping, a storage of related records. For example, students, you have many students being stored in a student table. You have many departments stored in a department table. So the department represents a generic a table represents a generic entity, collection of entities, whereas the column represents the attributes of the entities. For example, let's go back to our student class. So Java, let's say a Java class, maps. In Java, we have class, right? We have class, and this class, let's call it student, right? A student is an entity. A student is an entity, right, which can map into a table. So let's say database. So if we have a student, we have class. In a Java class entity, Java entity of class maps to, in database, it maps to a table. And then and then attributes of a class, or variables, variables in that class. Variables, let's use that. Variables or properties. I think properties would be better. Properties of that class map to what we call columns in the database. Columns in the database. So properties of a class maps to a column in database, and the class, which is an entity class, also map to table in the database. So having said that, we can now look at how does this work. Let's start with what we call key. Now, when we're dealing with map, we let's say ID maps to what we call a key in database. Key. The ID maps to key in database. So we have let's say we have an entity, and the entity has an ID. That ID can be mapped to a key. And what is a key? A key is the reference attributes of the many attributes that the class may have. The key or the ID is the reference attributes to locate that very object. The other time we wrote a method called find by ID. Find by ID. So in database you can also find by ID. And this time around, that ID is what is called key. Key. So the key is of different types. We have what we call primary key. Primary key. We have foreign key. And then we have what we call composite. Composite key. Composite key. Foreign key, primary key, foreign key, composite. Now, how do they form? For a primary key is like an ID, that is a single unique reference identifier. The what? The ID or primary key here. The primary key here is a single unique reference identifier. Primary key is a single unique reference identifier here. Single unique identifier. Single unique identifier. So I'll come back to that Satish. So single unique identifier, that's the primary key. Now we also have foreign key. Now, what is a foreign key? A foreign key is also a single unique. It's a primary key of a dependence object. A primary key of a dependence object, which means it is also a primary key. It's also a unique reference identifier. But in this context, let's take a look at a student. We have a student, isn't it? A student has an ID. And then we have address. Now, let's say the address has an ID. Now, in this context, if you want to reference address in student, then in database it will be address ID. Address will be referenced by the address ID. So the address ID, even though it is unique and is primary key in address. However, in student, it is a foreign key. In student table, it is a foreign key. In student table, this is a foreign key. In student table, this is a foreign key. Address table, which is address ID, in student table is a foreign key. Composite key is when you don't have a unique ID. When you don't have a unique ID, you can combine multiple columns together to form an ID. You can combine multiple columns to form an ID. Let's think of it. What can we do? Let's say we don't have ID for students, and we only have a table that contains student courses, student courses, which means I can have a student ID that also has that is containing a course ID, right? Now, so you can have multiple students here. You can have multiple students, having the same course, ID. So in this context, the student ID is not unique here. The course ID is also not unique, but you can combine the two. That will not be you can have a student ID and course ID to form a unique ID. So this is a composite ID. So this become a composite ID. This becomes a composite ID. This becomes a composite ID because what? It is not just a single ID. So we'll deal with that. Now, having said that, we can move on to look at our database and how Java objects or classes are translated to databases. Don't forget, we already said that a class could be mapped to a table, and the properties of the class can be mapped to a column. Now, so we move ahead, and then let's look at variables. Like in Java or JavaScript and things like that, you have different data type, or maybe let me call it data type or data structure. Like you have string, right? You have string, you have integer, you have a float. Just the same way you have it in Java, but you may not have things like a big decimal and co. How are these mapped in database? Oftentimes, the string is mapped to what we call character. Char. So a data type char represents single character. Char means a single character. Char, single character, one character at a time. And then we also have varchar. Varchar means variable character. Variable character, that is, it can contain multiple characters. So varchar is actually like string. Varchar equals to what? Equals to string. Your varchar equals to string. All right, so the varchar equals to string. So, and of course, you have like integer, which is the same thing as integer. You can have your float. You can have dates, depending on the type of. You have dates, and then we have what we call timestamp. That is date that has time with it. Timestamp means date with time. That is up till up to the milliseconds. No, we have up to milliseconds. Yes, we have day, you have month, we have a year, and then we have hour, we have minute, we have seconds, and then we have the milliseconds. We have the milliseconds. So this is how they are mapped. So having said that, the next thing that we need to introduce ourselves to is what is called SQL. SQL means that structured query language. SQL means structured query language. Structured query language. Structured query language, which has to do with a language of writing database related commands. Writing the database related commands, that is a generic language or ANSI language for writing scripts for database. So that is what structured query language is. So with this structured query language, we have already looked at data types. We have looked at char, we have looked at varchar, we have looked at int, we have looked at date, and we have seen the timestamp. Now, how does this command work? So let's start. We'll take a look at selection or query. Let's look at query. We'll look at query. We'll look at update. We'll look at delete. Coming back to our normal CRUDE that we talked about before. So we have query, we have update, we have delete. So the query is to read. Query is for reading, that is fetching data, whether single or multiple. The update is to update data in a table, and then the delete is to delete record, whether single or multiple, from a table. So these are basic commands. The other commands like create command, which means to insert record. I mean, not insert record, actually is to create a table, create a new table, just like saying instantiate a new entity, a new class, or construct a new class. So we have the create method to create a table or object now, and then we have the read is the reading, which is called a select. So I'll just say select here, select command to query and fetch or reading. So this is for reading or query. So if we take a look at this, we look at select, we look at update, we look at delete, we look at create. We have other advanced feature like grant. If we have time, we'll take a look at that, what grant actually is. And then we also have, maybe before grant, we have insert. Insert is to add new record to a table. To add new record to a table. Create can create anything. To create a new table can be used to also create the database. The create command can be used to create database. The create command can be used to create a table. While delete can also delete database, delete record from table, or delete database. Okay, we also have some other well, this one actually belongs to data maintenance commands. We also have a command called drop. The drop is to delete the entire table. Delete not just the content, it delete the entire table. Why delete a record from the table and still leave a space? The drop will remove the entire table. There is also something that is called truncate. The truncate will remove all record, remove all records with logical spaces. So that's like cleaning all record. The grant is to grant permission, permission or access rights to a user or role. So the grant is to grant permission or access rights to a user or a role. So the drop, delete the entire table or database, which means it has to be recreated, afresh. That is what drop does. So having looked at all this, we can start by creating, running some of these SQLs. Let's see how we can run some of these SQLs. We can start from first installing the database. Installing the database, you can actually go to MySQL page. Let's see here whether we can find a page. You can go to dev.install, go to MySQL to download the MySQL. After you have downloaded the MySQL, you need to install the MySQL. Install the MySQL. So there is some, let's say, you can go to devat.com, and you can download if you are using Mac OS. If not, you can also use you can download the version for Windows. You can download the version for Windows. Go to devat.com dbforge MySQL. Then you'll be able to see how you can download for Windows, for MySQL, and install it. While you are installing it, it will ask you to provide a root password. Make sure you provide the root password. And after you have done that, we can then go into working with MySQL. MySQL will be our reference database for this class. MySQL, let's use it as reference database for this class. Right. So let's go to the terminal. I'll go to the terminal now, and let's look at what we can do. First, let's log into our database. So if you have installed MySQL, ensure you have installed MySQL, and say MySQL. Let's see now. Type MySQL and then -u root and then -p. MySQL.u root and -p. So I hope you can see what I'm doing. If you're able to see what I'm doing, I think that will be fine. So I have MySQL that u root and then dash p. MySQL dash u root then dash p. The MySQL is for you to connect to a MySQL, and the u is saying that this is the user that is trying to log in, and then the p option is saying that this is the password I want to use for accessing MySQL. So you press enter. That way it can ask you for your root password. So I try to enter with my own root password, and I'm in. So I've logged in. So if you're able to log into your own MySQL also, I think you should be seeing the same thing that I'm seeing. You should be seeing the same thing that I'm seeing. If you're able to log in successfully to, MySQL, if you're able to log in successfully to the MySQL console, you should be seeing the same thing that I am seeing. So let's type C to clear the jargons or information on the screen. Let's clear the information on the screen. /C. And then, okay, so the first thing we want to do is that let's create a database for our project. Currently, we are dealing with students, and then we say bootcamp.edu. So let's create a database called Bootcamp. Let's create a database called Bootcamp, and we use our create command. So create database Bootcamp, and then terminate it with semicolon. Every statement we terminate with semicolon. The create, like I said, the create option is for you to create a logical file or a database. So there are many other databases that is existing. So if you want to see, I think let's see whether we can see that. Let's type show databases. Yeah. So with this command, we can see all the databases that already exist. We can see all databases that exist already in the MySQL server. So we have information schema, we have MySQL, we have a performance schema, and then we have a sys. So having said that, let's go ahead and create a new database. So create database, and we are going to call it Bootcamp. Don't forget, your database should represent your project. For those of you that that are building Uber application, so you can have the database called Uber. The one that is having order management, you can have a database called Orders. You can have a database called Orders, or whatever name you decide for your project. So we create database Bootcamp. Press enter. It should tell you that database query okay, one row affected. It means that one record is now created. If we write the command again, show databases, it should list our new Bootcamp among the databases. Our new Bootcamp should be seen as part of the new databases. Our Bootcamp should be seen as part of the new databases. You see? So we have created a database. Now, the show databases is that is inbuilt command for MySQL. For other vendors, it might not be the same. Like Postgres now, you might have to use something like LS to list databases. So now, after we have created a database, you need to make use of the database. And so how do we do that? Let's have another command called use database, or just say use bootcamp. Use bootcamp. What does this one do? The use bootcamp will switch the current database to our new database called bootcamp. If you want to maybe make use of a MySQL database, you can say use MySQL. If you want to make use of SYS database, you can say use SYS. So here we are saying use bootcamp. We want to make use of bootcamp database. You press enter. You will see that it has changed. You will see that everything has changed to what? Everything has changed to bootcamp. So you say database changed. Database changed. Now that we are here, what's the next thing that we need to do? First, we want to have an address table. If we go back to our address, so we need to create a table called address. Now, when you are creating a table, just like you define your class, our class has the properties. So we are going to have the properties created while we are creating the table. Great. So I'll probably switch back and write the query so that we can bring it back. Maybe not for the address. Now for the address, we have so that we can follow up properly. So I will list some of the command that we have used so far. So let me switch over to the VS Code. I'm switching over to the VS Code, and then so that we can have some of the command I've written so far to enable us to follow proper. So here, number one, we have show databases to list all databases. Then we have another command that we have written, and that command we ask was use database, or we have a create database. Now we create database in some and this database we gave it a name. We say bootcamp. That's the name of the database. We call it bootcamp. You can give it any name that you want, but for this class we are making use of bootcamp. Now after that, to add more performance stuff to it, we may be having other attributes that we add and things like that, but I will leave that for now. Then next, after we have created our database, then we will switch to our database by using the use command, use bootcamp. And then after that, we want to now create let's start with a table called address. And in our address we have address ID. Let's say address ID. We have streets, right? We have city, and then we have state. So those are the properties that we have. And our state is a string. Because our state is a string, we can say varchar. We'll say is type varchar. Now we can also design for every string has a total length of 255 in database. A table of a column has a 255 character. So that's maximum characters that it can hold per column. But if you are creating a table or a column and you do not specify the length, if you don't specify the length and you just say varchar, it will assume 255 as the length, which means that you are just making use, you are just wasting spaces. You are wasting spaces, you are wasting a logical memory space. So that is why it is always good to have a very good performance database or tables, specify the length or expected length of the character that you want. So let's say address now. I don't think any state will be more than 75 in length. So let's say it's 75 characters. Now city, also we can say 60 is 75 in character, right? Street, let's say the street is 25 or 30. Let's use 30 as the character. And then the ID is an integer actually, so you can see how we define it. This is our table definition of what? Of an address data, isn't it? Now, for the nomenclature, I would prefer that that each database represents a plural name of the entity class. Now, if the name of the class is more than one word, you join them by underscore. So here, the name of this class address. So I'll call it addresses in plural. So we have addresses, right? So if we now want to create a table with this structure, we just add a create command. We'll say create, and then what are we creating? The other time when we use the create, we put database at the type of the object to create. Here, the object we want to create is called table. So create a table. Here, when we put the create command database, and we assign the name of the database. Here, we assign the name of the table, which is called addresses. Now, we will now need to put more information. We now need to add more information. So how do we add more information? Put a bracket open and then bracket close. So create table addresses. Create table addresses. And in these addresses, we have ID, which is an integer. We have street, which is a varchar, right? Variable character. A string is a variable character. We have city, which is variable character, and then we have a state, variable character of what? Of 75. So this is how to create a table. Now we can go ahead to run and see whether this table can be created. So if we go back and paste it, if you go back and paste it, where am I? Okay, so if we paste it, if we go back to our terminal, If you go back to our terminal, we should be able to see the SQL code that I just posted for for table. So, and we can say, okay, show tables. We should see the new tables already created, which is called table addresses. And if you want to see the detail, we'll go into that. Now, so we have created addresses in what? In the Bootcamp table, We have created addresses in Bootcamp table. Now, but this table, even though it was working, we can't really see the relationship. So we need to add another modifiers in this table. Like we have classes that say private, public, and this. Let's add a modifier and mark the ID as our primary key. So what I'm going to do, I'm going to delete this table and recreate it. So drop table addresses. Drop table addresses. So that table is deleted. We want to recreate it. So we want to recreate the table, which is this. Create table addresses, right? And then here I will say sorry, I'll just mark this integer. We can mark this as primary key. Let's see whether this works. Okay, it works. So we have marked the ID as what? As primary key. Let's go ahead and create a students table. Let's go ahead and create student table. If you are still following, and you have not missed it, type following. Type following. Okay. So we move on. Let's create student table. So the same way we create addresses. So create table students. And the student, we have ID, isn't it? Integer, and we'll call it primary key. The ID is primary key. Then comma, we have name. What will be the maximum character of a name? Let's say 25, or at worst 35. Let's give the name 35 characters. So 35 characters. Varchar. So we say name Varchar 35. Name Varchar 35. What else? We also have address, isn't it? Because the student object has ID, name, and then the address. But the address is an object. So in the database, you don't instance an object to a column like that. Although there's a data type for objects, we get there. So instead of that, we make table address to maintain its own table. Because address is maintaining its own table, we will now put what? We'll call it address ID. Address ID. Address ID. Then integer. Because the ID in address is what? Is integer. But how do we know that this is referencing an address table? How do we know it's referencing an address table? We can see from here that even though it has address ID, it doesn't mean that it's actually referencing address table. You understand? So we will now say foreign key. Foreign key. We'll now put the table. What's the name? Addresses. Addresses. Let's hope this works the way we want. Okay, so I will just save foreign key address is foreign address ID is foreign key. address ID as foreign key. Let me do this. Let's fix that before we move on. Okay, so the foreign key rather is what is the foreign key is address ID rather. The foreign key column is the address ID, abi. Foreign key address ID, then we'll now say references, the table, references, addresses, address ID. Here I'm going to put it in, let me put it in the okay, let's finish this first. Let's ensure that it runs first. References, where is it? I'm going to do it again. We have address ID integer, right? Address ID integer, and then I will now have foreign key addresses, references, references, references. So address ID, okay, let me put it here first. Let me put it in the notepad or VS Code and type it out there. No one go. Okay, let's go to VS Code. I will change to VS Code and type the code there, then we'll probably run it. Let's go to VS Code. So this should be create table students, create table students, and then we have ID integer, primary key, and then after students primary we have name, we say is vaca 30, right? And after the name vaca 30, then we have say address ID, we say is an integer, and then we say foreign key address ID, right? And we say address ID references, address ID references addresses. That's the table, address ID in table. So this is what we should have, and then we terminate it. Let's see how this goes. Missing column address ID. Okay, sorry, I think I know. In address we have ID for address. We have ID for address. So that's where I wasn't even looking at that. So let's see the terminal. So here, and we'll post this again. I'll post this again. So what do we have? Why am I still putting this? So references, addresses. Okay, so that's created. So we have create table students of type this, and then so if we go ahead and say show databases or show tables, we should have two tables now. So we have two tables. We have student table, we have address table. We have student table, we have address table. Okay, student table and the address table. Student table and the address table. So we have the two tables. So let's try and insert records. Let's do what we did the other time. Say 6. If we go to the addresses class, if you go to the app class, yes, in the app class we have this. We have all these students. Let's convert them. Okay, so let's I'm trying to here. So let's convert all the, let's have all the address for let's quickly check. Okay, we need to round up this session. In maybe we can have another third session after 1 hour break. In 5 minutes I want to round up this session. So let's see, let's quickly create the code. So here we want to create addresses. Here we have 3 addresses now. So when you want to put record into a table, you use the insert. So how do we do insert? For Donald Bello, we say insert into. You use insert into followed by the table name, and the table name here is addresses, and then you specify which table columns. We have ID, we have street, we have city, and then we have state. Then followed by values. Each string is quoted with apostrophe, and the state apostrophe. That gives us for the first address. The first address here, so let's say the address ID is 1. We'll put it this way. So we have address ID That is for, that's for addresses. If we want to create students, we'll now say insert into students. The same way we start to address, we say ID, we have name, and then we have what? We have address ID. Then you say values. The ID here, this is the first student, so we'll call it 1. And then the name is Donald Bello here. You put it in this, Donald Bello. And then the next one is the address ID. Address ID. The first address we created here is 1, so we'll put 1 as the address ID. 1 as the address ID. Let's go ahead and do the same thing. Let's go ahead and do the same thing for the rest. So I will just quickly copy this. We don't have time again. I'll quickly copy that. Undo. So let's do this. So this is 1, and then London Avenue, Ontario, CA. Okay, so and the student is this. So let's do the same thing for this. This will be second, third student. It will be third student. So this is probably where we are going to end up. For today, for this session. If it's possible, we have another session after the 1 hour. So what about the student details? Let's do this. So this is the second student. So this will be 2, and that will go for the second address. So that is for the second address. That's for the second address. Let's look at the third one, the third student. For the third student, it will just be for Drake. The third student for Drake. Third student for Drake. Third student for Drake. And then the address ID is 3. Okay, so we have our student details now. Let's see. Okay, this will be the third student too. Otherwise, it can give us an integrity error. Okay, let's try and run this. Let's try and run this. Okay, that's created. Okay, that's created. Let's check for renew your. Let's check for the second address. Second address. So if we look at the second address and I paste it on students, you will see that. And then for the third one, we do the same thing and put it So we can check the records we have. We say select star, select star from addresses. That should give us the list of addresses that we have. If we want to check also for students table, select star from students. That should also give us the student table. You can see the address ID in the student table and things like that. So we are going to stop here. In our next class, we will be taking a look at query, which is the select function, like I just did. The where clause, we'll look at the clauses in fetching data. So thank you so much for joining again. I see you around in